So good morning. Today I would like to share the smart antenna for smartphone for my bench inspection of my FYP project. And I'm Timmy Yip, and welcome. So today I would like to talk about the introduction first, and design feature, and my proposed design, and explain the result, the small demonstration of the design, the future improvement, and the summarization. So the basic theory for antenna is basically antenna is a bridge between the receiver and transmitter in communication channel. They connected to the transmitter and receiver respectively via transmission line. They are acting as a transformer in the communication channel, since they transform the transmitter from electrical signals to the mmWave and propagate to the receiving antenna and convert back to the electrical signals. So why is it important for a smart antenna, and why do we need it? So in the past, there are most likely antenna of the mobile devices are using the omnidirectional antenna, and in modern society you can see almost everyone holds more than a smartphone nowadays, and the cellular nature for the smartphone is essential for everyone, and the demand of the 5G development rapidly increased since the high speed performance are required by the society. And you can see there are lots of countries are developing the 5G frequency band with mmWave. For example, US, Canada, and European countries, and UK, or even China started developing, and other Asia countries such as South Korea and Japan. So why do we need a smart antenna, and how is it different? So let's come up with some disadvantage for the typical antenna first. What if we use the omnidirectional when huge number of users are sharing the same channel? They will interfere the signal between each other, and they will degrade the signal, and last but not least, they will slow the speed, which is undesirable for all of us. And the other problem is sometimes we need to send the signal to particular direction only, but for other direction are undesirable, or we do not need it. And however, for a typical omnidirectional antennas, the power radiated are equal at any direction. So there is a raise of power and energy in undesired direction. So how can we strengthen radiated power at the desired direction with same amount of input power? So let's start with smart antenna, and how could it solve it? So for smart antenna, basically clever. The smart means clever, intelligent, to optimize the efficiency, cost and time, size and power consumed. And what do we want to achieve from a smart antenna? Is we aim to transmit the signal to the desired direction, or to detect the direction of arrival while receiving a signal for reception. Hence, we can reduce the noise and co-channel interference. And how can we solve it? By using the beamforming and beam steering techniques. And we will propose Mimo techniques also to provide high-speed performance for 5G mobile network, which requires lots of antennas transmitting and receiving at the same time, with using 28 GHz to improve channel capacity using a high frequency band, since high frequency band have a very large bandwidth. So let's come with the beamforming and beam steering technique. The beamforming basically means the formation of a beam of energy from a set of phase arrays. If we change the antenna spacing or the phase of the signal for each antenna element in the array, we can change the shape and direction of the signal beam, but not only confine a particular direction. And constructive interference strengthens the signal in desired direction, while the destructive interference remove or reduce in undesired direction in those directions. And we can see the beam steering techniques, which is takes further of the beamforming of the concept, which we could adjust the angle of transmission by changing direction of the main of the radiating pattern, by using the shifting of the signal phase, and we can see the beam pattern direction can be changed. And why is that important? Through phase shifting, it allows us to send any direction we want without confining in particular direction only. But most importantly, we do not need to physically rotate the antenna, but just using a single algorithm. This is the proposed set of this phase array antenna, and we can see there are 6 patch antenna in the array, and they're connected to the same source, and we can apply the phase shift to each antenna with respect to the first antenna. And here is the dimension calculated by these equations, and this is the S parameter performance, which we are having the resonating frequency of 20.8 GHz, having return loss of 15.5 decibels, and if we consider the 10 dB impedance bandwidth, which are having 1 GHz bandwidth, which is quite large, and the VSWR, which is used to consider how well do the impedance of the antenna match with the 50 ohm transmission line, and lower the VSWR the better. And it reached 1.14 at the resonating frequency, and we usually consider 1 to 3 for VSWR, and we can see between these range we are having 4 GHz, which is very large. And for individual radiating element for each antenna, this is omnidirectional, but this is not what we want, since it's a low gain, low directivity. This is the much narrower angle, 40 from 100 degree to 14 degrees, and the gain 3 times larger, from 4 or 5 to 12 or 11. So why 6 patch antenna in the array was used? As we see, the directivity are much improved, and the main beam angle becomes much narrower. You can see from 1 antenna element to 6 array antenna. However, we can further increase the number of patch antenna array in the array. However, due to the size, the compact size in the smartphone, so 6 is enough. And directivity, we can see by steering the beam using the equation of the phase shift here. As we see, in this case we're using 45 main loop degrees direction, and by applying 157 degrees relative to the antenna port, we can see it deviates to the 45 degrees. This is the other way around. So last but not least, we're having Mimo Technique. Mimo Technique is basically allows many transmission or receiving antennas to work simultaneously in the design, and it is having a high data rate. It comes with high data rate, and unlike typical phase array antenna, they are each connected with its individual source, providing much faster data rate by enabling multiple antennas on the same device. And this is the proposed Mimo antenna with the phase array, 4 sets of phase array, and we consider using the iPhone 11 since I left iPhone, and we consider this as our patch antenna design. This is the smartphone dimension, and we place in 4 edge of the corner, and here we reserve some space for the camera. And if we compare to the initial stage of our project specification, having similar approach, but we can't implement for massive Mimo since it's most likely for base station instead of a smartphone. But we implement 4 Mimo with 6 patch antenna. I think it's enough, and we change from sub 6 GHz to 28 GHz due to the modern trend in these days. And I would like to share with you with a sneak peek of my work